Hi there, risk managers. Today I'm diving into a game-changing tool for your risk management arsenal: fault tree analysis, or FTA. FTA is a top-down deductive failure analysis tool. It's used in high-reliability industries like aerospace, nuclear power, and biotechnology. But it's valuable in any field with complex systems. So let's break it down. First off, FTA uses a top-down approach. It starts by identifying a top-level event, a major system failure like an equipment breakdown. From there, you work backward to pinpoint potential causes, known as basic events. FTA employs Boolean logic gates to represent relationships between events. The two primary gates are the AND gate and the OR gate. An AND gate means multiple failures must occur simultaneously to trigger the top event. An OR gate means the failure of any single component can cause the top event. The resulting diagram looks like a tree, with the top event at the root and the basic events branching out. This tree structure visually maps out how various combinations of failures can lead to the top event. Now, let's walk through the steps of conducting an FTA. First, define the top event. Identify the undesired outcome you want to analyze, such as system shutdown or equipment failure. Second, construct the fault tree. Start by brainstorming the immediate causes of the top event, connecting them using and or gates. Continue working backward until you reach the most basic level of causes. Third, analyze the fault tree. Identify minimal cut sets, which are the smallest combinations of basic events that can trigger the top event. If needed, perform quantitative analysis to assess the likelihood of the top event, based on the probabilities of each basic event. Use the insights from your FTA to identify system weak points and propose changes. This could mean adding redundancy, enhancing maintenance procedures, or improving quality control. Why is FTA so important? First, it's excellent for risk identification and mitigation. FTA offers a structured way to uncover all potential causes of a system failure, enabling preventive actions to reduce the likelihood of critical failures. Second, FTA helps improve system reliability. By visualizing how different components and processes contribute to failures, FTA aids in refining system design and boosting reliability. Third, in safety-critical industries, FTA supports compliance and safety by meeting regulatory requirements for understanding potential failure modes and their mitigation strategies. Fourth, FTA is great for root cause analysis, drilling down into why and how systems fail, leading to more targeted corrective actions. And lastly, FTA helps in cost-effective maintenance and testing. By identifying critical failure modes, organizations can prioritize maintenance and resource allocation more efficiently. In the biotech and pharmaceutical sectors, FTA assesses risks in complex manufacturing processes, product quality, and regulatory compliance. For example, in a biopharmaceutical company experiencing a contamination event during production, an FTA helps identify causes like sterile filtration failure, human error, or equipment malfunction. In conclusion, fault tree analysis is a valuable tool for understanding and mitigating system-level failures. Its structured approach ensures thorough analysis and prevention of potential failures, enhancing reliability and safety in critical industries. Thanks for watching. If you found this useful, don't forget to like and share. Until next time, keep those systems running smoothly.